little algebrainiacs. Welcome to the Johnson Kendra Video Hour.
But it's not an hour.
Okay, if you say so. One of these days, I'm telling you. To the moon with you. Okay. That was a little unnatural. So we'll talk about natural logarithms and natural log function. So think about this. If y equals e to the x, remember
Wait,
that
whoa,
number?
whoa, whoa, E.
E, that was that number, that irrational number we talked about, was approximately 2.7-ish. Okay. We use that in the PERT formula.
Per plus?
PERT plus. Yeah. Sure. At least you wrote it in green. Okay. So, we're going to convert to the log form. That's exponential. So then it's log base e of y equals x.
Are they ever going to see this, ever? In math language?
No.
In Johnson-Kendra language, maybe?
Yeah, we abbreviate that. Mathematicians, remember, are lazy, and they call it log base e. They call it ln for the natural log.
Wait a minute. Natural log would be NL.
Yeah, that kind of makes sense, but I think back when the Frenchmen figured this out, they called it logarithme natural. So we do ln instead, and it just stuck. So we're just going with it.
So these natural logs, the cool thing is all the properties and stuff you guys have already learned still apply here. So.
All right, so we're going to write as one log, so we need to combine those into one. So that 5 out front, that still makes it the exponent. So we have natural log of 2 to the 5th minus natural log of 4.
What's 2 to the 5th?
32.
Okay.
Let's change that, yeah, make it simple. Now, subtraction
means division.
So we take natural log of 32 divided by 4.
Which is?
8. So that is 1 log. You don't have to figure that answer out. We just wanted you to convert it to 1 log. Ooh, here's another one. We got a couple numbers out front, 1/4 and 1/4. So we put those as the exponents again. And, yep, natural log of x to the 1/4. Okay, 3 to the 1/4, x to the 1/4. We might have to do something later with that, but right now we'll change it to 1 natural log. Make it multiplication, so 3 to the 1/4 times x to the 1/4.
What's a 1/4 power?
It's a quadruple root.
Fourth root?
Or 4th root, yeah.
Okay, we can put them under the same, by the way.
There we go. So we had to put them together because they were the same exponents.
So that's just using those properties. Alright.
It's proper to do those properties.
Alrighty.
Alright, same thing here. We're going to solve this. We're going to change it to exponential. So what base goes with that natural log?
Okay, when I see ln, what I'm thinking in my head is log base e of x.
Right.
So maybe that will help some of them.
Yeah.
Because this is like our base, this is like our x, this is like our y.
Okay.
So we would say base
e to the 0.1 equals x.
Oh, I can just type that on the calculator.
Yeah, baby. E is a fancy schmancy little button, and raise it to the 0.1, and what do you get?
Round it.
Very nice. And then you can check that, but remember when you round, it's going to be off by a tiny bit. And there is a button on your calculator, the ln button. You have to search for it a little bit.
It's right by the e. If you don't hit second, then you would be lning instead of eing.
And you might get in trouble for that. Okay, so we have another base e here.
So I'm thinking in my head it's log base e of 3x minus 9 equals 21.
Okay, so then
This
e
base,
to the 21. Whoop.
What is this? This is the y. Okay, so e to the 21 equals
3x minus 9.
This is going to be huge.
E to the 21, yes, because
so I'm going to just leave it in the calculator.
Some big old number.
But you should get that answer and leave it in the calculator. And then what algebra steps will we use?
Add 9 to both sides.
Add 9 to the big number, leave it in the calculator, and then what?
Divide by 3.
Still big number.
Sort of big number now.
Yeah.
Or actually bigger number. But when we
9 bigger.
Yeah, then when we divide by 3, it's a sort of big number. Alright, I got the calculator out. X equals 439,605,247. Yeah, that's a sort of big number. 0.8. Okay. Anything raised to that big of a power is going to be pretty gigantic. Might I say you're a natural at these natural logs?
I've had a good teacher.
Oh, wasn't me, I don't think. Am I going to take that as a compliment? I don't know. All right, here we go again. So e to the 12th equals x plus 2 over 3. So again, e to the 12th is going to be a pretty big number. Miss Johnson's fast on that calculator.
So should I just leave it in there, or should I round at this point?
No, always leave it in there.
All right, what's next?
So then we multiply by 3 and leave that big number. And we should get, 488,264.3743, dot, dot, dot. And then the last step is subtract 2. So that only changes this to a 2. So 488,262.3743. And that is our final answer, rounded to the 4th place.
So let me get this straight. We were given natural log equations, and to solve them, we converted to exponential form. Whoa, isn't that what we did in
last section?
5? But this was just with e instead of base 10.
So you gotta just get used to that e being your base.
So let's go the other way.
Okay. Well, this time
we need it to be like b to the x equals y.
Okay.
So the problem is this thingy.
Huh.
What should we do with that?
Does that come back out top with the other exponent?
I don't think so.
So we divide by that. Okay.
So it's that property, you're thinking power property.
Right, but there's no log there, so we can't do that.
So we gotta get rid of it.
But we have to isolate the e part in order to get started.
So e to the x plus 1 equals 30.
Right.
So this is the b, this is the x, this is the y. So log base b of y equals x. Now what is that really?
Log, natural log.
So that's what you're going to type on the calculator.
Okay. And we can do ln of 30.
Yes.
And then subtract.
So that's 3.40, 1 dot dot dot, and then equals x plus 1. I have trouble when we get to the bottom here. So then we will do what?
Subtract 1.
Subtract 1. So then that's 2.4012 when we round.
Okay. Very nice. Yeah, the rounding, just be aware. One more over here. Okay, we've got an e. We got to get that isolated, so we're going to
e to the x alone
equals y. So let's get rid of the 7 too. So subtract.
So what's that?
1.9.
Okay, so this is the b, this is the x, this is the y. So log base b of y equals x.
Okay.
But what is that really?
Natural log of 1.9.
Which we can do in the calculator.
Could I just multiply by 5 halves instead of multiply by 5 and divide by 2?
Totally.
Nice. So natural log of 1.9.
I'm not rounding yet.
And multiply.
And then you said to get rid of that, I could multiply by
5 halves.
Oh, you're so smart.
Then we just have one step. Remember, mathematicians are lazy, so the more you can do with one step, the better will be. All right, and that's rounded.
Okay.
Again, if you're going to check, it will be off by a tiny bit.
So why do we need these things?
There are issues out in the real world that all this stuff and investments are a big part of it.
So it says an initial investment of $200 is worth $315.24 after 7 years of continuous.
Ooh, that's that APERT So you're telling me we're gonna make over $100 by doing nothing?
Yeah, if the interest rate is good enough.
Nice.
I think I had the formula under here. Yeah.
Oh,
I forgot.
there it is. But we knew it anyway.
Yeah, it's awesome.
Now we got to remember what everything stands for.
What is P?
P is your principal, your first starting amount.
Is this like principal or one of these principals?
Principal. Principal, if it ends in PAL, that
like
means
Mr. Gilchrist.
Gilchrist. He's our pal. So remember principal. And the A means the end amount. R is your rate of interest.
That's got to be a percent as a decimal.
Right. T is the time involved.
That's got to be years.
In years. Okay.
So this is a different kind of problem than we've done before because we know the end and the beginning. What we don't know is the interest rate. So we're solving for an exponent. That's why we need logarithms to solve for exponents. So let's fill all the stuff in. Where does the 200 go?
That goes in for P.
So that's going to go here.
E
then,
is just there.
Right. So
R is just there.
We don't know the rate.
Right.
We do know the time is 7.
And then A is 3:15:24.
Okay, so you could change this to 7R. I was just trying to follow the formula.
Right.
Now, am I ready to switch to the...
No. You always got to isolate the log or the natural log or the E or whatever it is that is the variable.
So,
all right?
1.5762, that's not rounded. Okay?
So now we're back to problems like we had before. So we can take natural log 1.5762 equals 7R.
So we're going to get this answer and then do what with it?
Divide by 7.
Okay, let's do that.
All right, get that on the calculator. All right.
Now, what does that mean?
That is a decimal, but we need to turn it into percent for the rate. So move your decimal twice, end up with 6.5%. Ooh, that's a pretty good percent.
That is a high rate.
Usually it's 1 or 2%.
Yeah, I need to go to that bank.
No kidding. All right, folks, that is it for this chapter. You know what that means. We feel smart. And log R, what does that say?
It's logs.
Oh, logs. We heart logs. Yes, we do. All right, and we heart you too. Ta-ta for now.